Hi everyone. Today's lesson focuses on calculating compound interest, which is sort of a standalone topic in Chapter 7. I really think it fits in with the powers and exponents stuff that we've been talking about, mostly because the formula that we're using deals with an exponential function. Okay, but we'll talk about that in just a few minutes. So what do I mean when I say compound interest? Compound interest, and I've got sort of a definition there for you, when the interest is combined with the principal and used in the next interest calculation. A shorthand way of saying that would be when you earn interest on interest, okay? And that sounds confusing, but let me show you what I mean. So let's suppose you go to a bank and you say, I'm going to deposit $100, and the bank says they're willing to pay you 5% interest compounded annually, which means once a year. That's a pretty common way to calculate interest. Okay? What that means is you're going to start with $100, okay? And at the end of 1 year, the bank is going to increase the money in your account by 5%. So 5% of 100 is $5. And so you're going to get an extra $5, $5 of free money added onto the account at the end of the first year. Okay? Now, if you leave that money in the account for a second year, it's going to earn interest again, but now you're earning 5% of this number, and you already got some free money in there, so now you're earning 5% on that free money that you got. Just so you can see the calculation that I'm doing here. If I take 1.05 and multiply it by the 105, that's a 5% growth, right? That's what that's talking about. Now I'm actually going to have 110.25. So you'll see that here I increased by $5. Here I increased by a little more than $5. I increased by like $5.25. And if I left this in here for multiple years, every year I would gain a little bit more than I did the year before. Okay, just based on the fact that the interest is being compounded, meaning I'm getting to earn interest on that free money that the bank already gave me. That's what it means to be compounding. Okay, compounding interest means you're earning interest on the free money that you already got. Now, there's other ways that banks can do this calculation. So, for example, I mentioned compounded annually means just at the end of 1 year, they're going to add 5% to your account. Maybe you're going to go, though, to another bank, and they're going to take that same $100 that you're investing, and they say, I'll give you 5% also, but I'll compound it semi-annually. Semi-annually means like halfway through the year. Okay, so here's what that means they're going to do. They're going to take that $100, and halfway through year 1, so after 6 months, they're going to give you half of your 5%. Okay, so they're going to give you 2.5% interest. And so I'm doing 1.025, that's 2.5% interest, times 100, and that means that now I have 102.50. And then at the end of that year, so after another 6 months, they'll give you the other 2.5%. But that second 2.5% is being calculated now based on this number instead of this number. Okay, so if I take that 102.50 and multiply by 1.025 again, now I'm at $105.06 roughly. So look at that compared to the other bank. The other bank at the end of the year you had 105. Here you have 6 cents more. And I know that doesn't seem like a lot, but again, you have to kind of project this over time. So if I were to go another year, so after halfway through the next year, I multiply by that 1.025 again. Now I'm at 107.69. That would be after like a year and a half total, so halfway through the second year. And then if I do it one more time, I'm at 110.38 as compared to 110.25. So you'll notice that the difference, they're starting to pull apart, right? This one is going to be larger than this one, and every year that difference is going to grow, okay? So semi-annual interest gives you the extra benefit of earning interest on top of interest halfway through the year as well. And then another bank might come along and say, all right, I can beat that. We'll compound 4 times a year, or 8 times a year, or 12 times a year, okay? So that is what compound interest is really referring to, is this idea of we'll give you 5% total. I mean, we gave you 2.5% and 2.5%, so that's still 5%. But by giving part of it to you halfway through the year, that gives you an added opportunity to earn more free money. So I was kind of doing that by hand, right? I was just kind of roughly estimating from year to year. I also chose some really easy numbers to work with here. We have a formula that's going to take care of this for us, and that's this big formula here. And that runs all of this calculation kind of in one shot. So let's just make sure we know the parts of this thing. P stands for principal. And in banking, when I'm talking about the principal, that's the initial investment. So in that example I was doing just a minute ago, the $100 that I walked into the bank with would be my principal. R is my interest rate. That's my annual interest rate. And it is important to note that that's going to be given to you as a percentage. You need to make sure you change it into a decimal before you put it into the problem. And by that I mean you're going to have to move the decimal place 2 to the left. Okay, N shows up here twice. Okay, and N is referring to the number of times per year the interest is compounded. And so again, referring back to this example that I did back here, in this one when I compounded annually, that would just be N equals 1. But when I did it semi-annually, N would equal 2. And then last thing we have here is the T, and that represents time. It is important to note that time always has to be measured in years in order to line up with how your interest rate and your N value is calculated. Okay? But really, when you get into the examples here, the examples are just going to be word problems that give you all of these pieces of information, and your job is just to put them in the formula. Okay? A quick word on the N values, and I'm going to put a note here to see below. The N value is always given to you verbally. It's always given to you in word form, and you have to know what number each of those words represents. So if you look down here, there's this list of words that you could see show up in one of these problems. If interest is being compounded annually, that's 1 time a year. So you would say N equals 1. Semi-annually, which we already talked about, is N equals 2. Biannually really does not come up all that often. Okay, I don't know if I've ever seen it in one of these problems, but I really just put it on here so you can see the difference between semi-annually and biannually. Biannually means every 2 years, which means as far as how many times per year, we would say 1/2 here. Okay, that's the difference between semi and biannually. Quarterly would be 4 times a year, and monthly would be 12 times a year. Okay. And there's some other possibilities. I think on your homework you're going to do one. Ignore that. You're going to do one that's daily, so you would put in 365. They could even just give you a number. They could say we're going to compound 5 times a year, and then your N value would equal 5. But these are some of the most common ones that show up. Okay, so let's actually run through one of these. Okay, so example 1. Take a second, read that problem, and see if you can identify the P, the R, the T, and the N. So all 4 of those things are given to you here. P is your principal. That's your $1,000 here. Your R value is here. And remember, you have to move this decimal point 2 to the left. So this is going to be 0.0525. Common mistake on this one, by the way, is people forgetting to move that decimal point. If you put this number into your formula as a 5.25 instead of this decimal here, you will get a ridiculously large answer. So if you're doing one of these problems, you get a number that doesn't seem realistic, that would be the first thing I would check, is that you did the R value correctly. Okay. It says it's being compounded quarterly, so this means your N value is a 4. And then the value after 2 years, so this gives you your T value here. So when I plug it into the formula, this is what it's going to look like. A equals P, which is 1,000, 1 plus my R value, so 0.0525, divided by 4, because it's being compounded 4 times a year, to the power of 4 times, notice these two numbers are exactly the same, times 2 for my time. I do want to see this written out on your paper for your homework, so I am expecting to see this formula set up written out on your paper. So now let's put this thing in our calculator, okay? And it should go in pretty much exactly how you have it written on your paper, with maybe one exception. So I'm typing it in 1,000, parenthesis, 1 plus 0.0525 divided by 4, parenthesis, to the power of, and if you've got a calculator that does this thing where it just gives you the power symbol and then you just keep typing, you will need parentheses around the 4 times 2. Or you can just make that an 8, okay, and type it in directly. So you may want to check on parentheses there, otherwise it should look just like that. And we end up with this answer, 1109.95. So now the question we want to make sure we ask ourselves here is, does that seem reasonable based on what we started with? Well, if we started with 1,000 and we ended up with 1109, that seems pretty reasonable. If you started with 1,000 and suddenly after 2 years have $7.4 billion, chances are there's a mistake somewhere, like your interest rate was typed in wrong. Okay, so just take a second and think about your answer before just blindly writing them down. Okay, that right there really covered like a majority of what this lesson is all about. When you look at the homework, most of the problems look just like this example 1. There is one other quick thing we need to mention, and that's annual yield. And the banks are required to report that information right alongside your annual interest rate. So what's the difference between the two? So let's go back to this example that we started with here. And if I look at this one where I was compounded semi-annually, they promised me a 5% interest rate. And I got that because I got 2.5% and 2.5%. But if I just look at the change from the beginning of the year to the end of the year, that's actually more than 5% growth. From 100 to 105.06 is 5.06% growth, okay? And I only know that just from looking at these numbers because I used such an easy number here. I used 100, okay? But I can see that this grew by more than 5% because 5% would have just given me 105. So this right here is what's referred to as the annual yield. How much do you expect your money to actually grow from the beginning of the year to the end of the year? And if you're compounding more than once a year, I would expect this number to be just slightly larger than where your interest rate is, okay? So let's say you didn't have all of this worked out on paper so nicely and you just wanted to calculate annual yield all by itself. If we take that formula that we've been working with, and as far as annual yield, we don't care about the actual amount in the account. We're only looking for the percentage. So I don't need a principal put in for annual yield. And because I'm looking only at annual, I'm looking at 1 year, I don't need to put in a value for t because I just want to know what will there be after that 1 year. Okay? So this piece of the formula right here, is what gives you your annual yield. When you do this calculation, you're going to get something like 1 point something 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 something. Okay? This part right here, this decimal part, this is the part that I'm looking for. Okay? And we want to write this as, this would be the annual yield. And we're going to take that decimal and write it back in percent form, ignoring the 1. Okay, we'll get rid of the 1 once we have found our annual yield. Okay, because that 1 is really just meant to represent growth. Remember how when we were doing this on the calculator before, let me find it here, I was multiplying by 1.025. That 1 in front is just saying that's what you're growing by. Okay. So if you read example 2, you'll notice it sounds similar to example 1, except they don't give you a principal and they don't give you time. That's because you don't need those two things for annual yield. So I am just going to do 1 plus, for my R value, I'm putting in 0.032 divided by, let's see, this is compounded semi-annually, so that's twice a year. And then I'm just going to the power of that 2. Okay, so that's all I'm doing for annual yield. I'm going to type that straight into a calculator. So I'm going to go 1 plus 0.032 divided by 2 to the power of 2. And this gives me 1.032256. So again, I'm ignoring the 1, and then this thing I'm going to turn into a percentage. So I'm going to say this is, if I move that decimal 2 to the right, I get 3.23%. I just rounded this 2 up because of the 5. Okay, so this becomes 3.23%. If you look at it compared to the original interest rate, it is just slightly higher. 3.23 is a little bit higher than 3.2. That's the annual yield. Okay. Okay, that's really it for today. Your homework for tonight is Lesson Master 7-4. Check Blackboard for details on which one you're doing. And I do want to remind you that any of these problems you're working through, I do expect to see this work shown out on your paper for you to get credit. Okay? All right, that's it for today.